All right, so the discriminant is the b squared minus 4ac. That's the expression for the discriminant. Notice it looks familiar. Where did you see this expression at? That's your radicand of the quadratic formula. Right? But that's the discriminant. It's just b squared minus 4ac. Now, one of the things the discriminant does is it tells you how many solutions you will have, how many distinct solutions you will have, and what kind. Right? So how many distinct solutions there are, and what kind they will be. Later on, you're going to learn that one of the other things it could tell you is if, when we start graphing, we're going to graph these quadratic functions in another chapter, but it will tell you whether you're going to have x-intercepts or not. You can get that from the discriminant. Will the graph cross the x-axis, or will the parabola not cross the x-axis? Or will it touch the x-axis only? So those are all things you can do from the discriminant. Well, the discriminant is at b squared minus 4ac. So if you have, let's say number 1, so the directions will say something like use a discriminant to determine how many and type of solutions each quadratic equation will have. So use a discriminant to determine how many and what type of solutions each of the following equations will have, without actually solving it, because you don't want to do that whole process. Remember this whole process that we did here? That's not what you want to do. Okay? Here, what did I do? I solved the equation. I actually found the solutions, right? The solutions are these. That's not what this is saying. This is just saying how many solutions will you have and what kind. That's all it says. So what allows you to do that? What's that called? The discriminant. That allows you to answer this question. So when doing this kind of problem, if you do all of this, you're not going to get full credit, because it implies that you really don't understand what you're asked to do here. All you're asked to do is just use this expression right here, find out what that is, and then answer the question. So it's not asking you to solve this equation. I don't want to know what the solutions are here. I just want to know how many there will be and what are they. So for example, in this case, how many are there? 2. What kind are they? Irrational. You're done. That's what they wanted to know. I don't have to go through all this, though, to determine this. All right, so here's what you would do. Okay, so number 1, I'm going to go ahead and use some of the same problems I had earlier. So let's say we had 5x squared minus 2x minus 2 equal 0. So I want to know how many solutions there will be and what kind. That's all I want to know. I don't want to know what they are. I just want to know how many and what kind. So we can do the discriminant. So I still have to determine A, B, and C, because if you look at the formula for the discriminant, your letters are A, B, and C. So it's got to be in general form. Is this in general form? Yes. So what's A? What's B? And what's C? -2. So if I plug these back into the discriminant, so the value of the discriminant is, all right, so B squared. What's B? Put that in parentheses, just like it did when we solved those equations. I squared minus 4 times A, what's A? times c, which is negative 2. What's negative 2 squared? What's a negative 4 times 5 times a negative 20?
Positive 40.
Positive 40. So what's the value of the discriminant? 44. So that's the value of the discriminant. So when you get that worksheet, you're going to see a column that says value. You're going to put what in that box? 44. Okay? Now, 44, here's what you got to think of now. Is 44 positive or negative? Positive. So if I were to solve this, at some point you would say the square root of what? 44, right? And then we ask ourselves, can I simplify the square root of 44? Remember all that? Is 44 perfect square? No. So what kind of solutions do we end up with? Irrational. All right? So here's the idea. 44, you're going to ask yourself, is 44 a perfect square? Yes or no? No. So since 44 is not a perfect square, I will get 2 irrational solutions. I will get 2 irrational solutions. Kind of makes sense because look, right here, square root of 44, what do? We simplified it. You still end up with what kind of solutions? Irrational. How many were there? There were 2. There were 2 of them. So find the discriminant. If it's not a perfect square, you say what? 2 irrational. All right, let's look at this one. Okay, so let's suppose we had 6x squared minus x equal 12. So 6x squared minus x equal 12. And again, I just want to know how many solutions will I have and what kind. So what are you going to use to determine that without actually solving the equation? The discriminant. So b squared minus 4ac. But before we do the discriminant, just like we did if I were going to ask you to solve this, this equation must be in what form? No, it is quadratic, but you meant what? General form. So you're going to have 0 on the other side. So you can bring the 12 over, put in descending order. So I get 6x squared minus x. What else? Minus 12 equal 0. All right, so what's A? What's B? Negative 1. What's C? Negative 12. All right, so the value of the discriminant is, and then that's at b squared minus 4ac. So what's b in this case? What do I do to a negative 1? Square it. Minus 4 times a. What's a? 6 times c? Negative 12. All right, use your calculator if you need to. Negative 1 times itself is 1. You needed a calculator for that part. But what's in, you may need your calculator for the next one. What's a negative 4 times 6 times a negative 12? 288. Positive 288? Yeah. Which gives me 289. Okay. All right, so the value of the discriminant is what number? 289. Now, all you do is ask yourself, is this a perfect square or not? Yes. Yes, because if you take your calculator, take the square root of 289, that's what you would do. Square root of 289, and see if you get a whole number or not. I get what? 17. So it is a perfect square, because 17 times 17 is what? 289. So now here's what's going to happen. Think about if you were to actually solve this. At some point, you would end up with the square root. At some point, you would end up with the square root of 289, right? If you would actually solve it. But 289, the square root of 289 is exactly what? 17. And then if you recall, all the examples we've done with the quadratic formula, we asked ourselves, will I end up with rational or irrational at this point? Rational, because you have 17, not a square root. So the idea is this. If the value of the discriminant, so since 289 is a perfect square, you will get 2 rational solutions. So far, all it is just determining once you find the discriminant, once you find the value of the discriminant, is determining is it perfect square or not. If it's positive, right? So both of those numbers are positive. So since they were positive, it's either going to be rational or irrational. If this was negative, it would be what? Imaginary. So since it's positive, your answer is going to either be 2 rational or 2 irrational. If it's a perfect square, it's going to be 2 what? Rational. If it's not a perfect square, it will be 2 irrational. All right, let's look at this one. Number 3. All right, suppose we had 3x squared minus x plus 2 equals 0. So 3x squared minus x plus 2 equal 0. So first of all, is this in journal form? Yes. So what's A? What's B? -1. And what's C? 2. So you just want to know how many and what kind. So use the discriminant. You got to be using discriminant. Don't solve this, because you're not going to get full credit if you do. You got to tell me the discriminant. So the value of the discriminant is, okay, b squared minus 4ac. So what's b? -1. When I square it, I'll get 1, right? So, but it'll be -1 squared minus 4 times a. What's a? 3. Times c? 2. So I'm going to get +1. Now what's -4 times 3 times 2? -24. So what's the value of the discriminant? -23. So that would be the thing on the radicand, right? That would be the radicand. But if you were to actually solve it, you would be saying, well, I'm taking the square root of a -23, which we know is, you would end up with that I, right? So it's going to be what kind of solutions? Imaginary. How many? 2. So since the discriminant is negative, you'll get 2 imaginary solutions. Now remember, we used the word complex numbers before. Now all these numbers are complex numbers. If you have the solution 5, 5 is a complex number because you can write as 5 plus what? We talked about that. 5 plus 0i. Okay? So every number is a complex number. But on your worksheet, there's going to be columns that are going to be complex imaginary. So that complex column just means you're dealing with complex conjugates. So it turns out, and you learned this in another section, but it turns out that if one of your solutions is imaginary, then its conjugate is also going to be a solution. So you'll notice that they occur in conjugate pairs. So in that column, you're going to see what it's going to look like. In that column, the last column where it says complex, it doesn't mean just complex number. It means a complex, and it's what kind of complex number? Imaginary. All right, so it's in parentheses. You'll see it. It's in parentheses. Okay, so if it's positive, you got to determine whether it's a perfect square or not, right? If it's negative, it's easy. It's going to be what kind of solutions? Imaginary. If it's positive, it's either going to be rational or irrational. It'll be rational if it's a perfect square, irrational if it's not a perfect square. All right, now let's look at this. Suppose I asked you to actually solve this equation. Solve this equation. Nine x squared minus 24x equal negative 16. All right. So we're solving this time. We're solving. So the direction says solve, then how would you solve this?
First thing you got to do is
You're going to use a quadratic form, but first of all, you got to make sure it's in what form? General form. So it'd be 9x squared minus 24x plus 16 equal 0. All right. Now what's A in this case?
9,
B
24,
and C.
16.
All right. So I'm going to get x equal the opposite of B. What's the opposite of B? 24 plus or minus the square root of negative 24 squared. Now remember, what I'm writing is a discriminant, right, underneath? Okay. 24 squared minus 4 times A. A is, that's a 9. Times C, which is 16. All that is being divided by 2 times what? 9? Okay, so let's look at the discriminant. 24 plus or minus the square root of, use your calculator, what's a negative 24 times itself?
576.
Okay. What's a negative 4 times 9 times 16? Minus 576. All over what number? Okay, now let's look at the discriminant. What do you notice about the discriminant?
0.
It's 0. Discriminant is 0. So we have this. We have 24 plus or minus the square root of 0 all over 18, right? But what's the square root of 0?
0.
0. So that's 24 plus or minus 0 over 18, right? 24 plus or minus 0 is still what?
0.
No.
No. Oh, no.
24.
Yeah.
So I don't have that plus or minus like I did in all the other problems, where I ended up with how many solutions? 2. Here you end up with how many solutions? 1. 1 distinct solution. I reduce it though. 24/18 would be 4/3. That would be your solution.
So one rational.
1 rational. 1 rational. You know it's not going to be irrational because the square root no longer existed. So now we know this. We know that if your discriminant is positive, it's either going to be 2 rational or 2 what? Irrational. It will be 2 rational if the discriminant is
Perfect square.
perfect square. It will be 2 irrational if the discriminant is not a perfect square. You're going to end up with 1 rational if your discriminant is what?
0.
0. So if the discriminant is 0, you will have 1 rational solution. Now all that plays into graphing, how many x-intercepts you will have and all that. Okay, so that's discriminant. Just tells you how many and what kind. All right, so when you look at the worksheet, let's go ahead and end this.